Hello, my name is Alexander Chuyeshev, and today I'm glad to present our work expanding the number of reviewers in open source projects by recommending appropriate developers. So, why could it be helpful to expand the number of reviewers? First, it promotes knowledge sharing among the contributors. Second, having sufficient reviewers allows balancing the workload without putting too much burden on a few key persons. To expand the number of reviewers, we can, for instance, recommend experienced reviewers from outside the project. However, the problem is that invited reviewers need time to adapt and get the context of the project. So, are there any strategies that don't depend on such external recommendations? To identify them, we have conducted an exploratory study. In this study, we found that contributors follow three roles: developer reviewer, plain reviewer, and plain developer. One strategy to extend the set of actual reviewers could be to recommend plain developers, and each project has such an opportunity. We have also found that each project contains contributors with little reviewing experience but sufficient development experience to perform more reviews. We call those contributors low-intensity developer reviewers. So another strategy might be to recommend them as well and encourage to participate in additional reviews. To summarize, we can make recommendations of plain developers and low-intensity developer reviewers, but we cannot recommend random persons. We must ensure that the selected persons will be able to perform reviews successfully. To make appropriate recommendations, we have implemented a recommender system called REX. REX relies on the development and reviewing history and doesn't require any explicit interactions from the contributors. It can handle any development language. REX takes into account that contributors may know parts of the system to which they don't explicitly contribute. Finally, REX is able to recommend both regular and new possible reviewers. To achieve this, we have built REX on top of collaborative filtering or other metrics factorization. For a given pull request, our system first suggests regular reviewers, then it suggests new possible reviewers from among the appropriate plain developers, and finally, REX aggregates all previous suggestions and reruns them to make the top end recommendations. So let's take a closer look at each step. The first step relates to the metrics factorization algorithm called IALS. By applying IALS over the history of reviews, we obtain two things: the abstract contributors reviewing preferences or development preferences if we speak about the history of commits, and the file profiles. That information is further used to make several things. First, to identify similar developers based on their preferences, and second, to recommend reviewers by estimating their reviewing scores with the dot product. And the second step, for each file of a given pull request, REX recommends top K reviewers and merge them into a single set. This set may include both plain reviewers and developer reviewers. If developer reviewers are presented, then REX attempts to expand the set of actual reviewers. If not, then it recommends only regular reviewers for this pull request and skips the third step. Suppose that the third step is not skipped. And this way, for each recommended developer reviewer, REX suggests top K similar plain developers. Then, for each found plain developer, it estimates a possible reviewing score that this person can get being a reviewer. The hypothesis for estimating this score is that contributors with similar development preferences may also have similar reviewing preferences. In the final step, REX receives two sets of candidates to recommend. The first set contains reviewers whose reviewing score was estimated with the dot product, and the second set can be empty or contain appropriate plain developers, and their reviewing score was based on our hypothesis. REX aggregates those sets by taking the sum of reviewing scores over the set of pull request files. Then it sorts the results in descending order and recommends the first n candidates for the pull request. So to evaluate our recommender system, we posed two research questions. The first is how well is Rex able to predict regular reviewers compared to existing approaches? And the second is Rex able to expand the set of actual reviewers? To answer the first question, we have compared Rex with TIE and Refinder. So, Rex shows lower results than TIE, but close to Refinder. However, Rex recommends not only regular reviewers, obvious to authors in advance, but also new potential reviewers. It looks like always asking who else can review the change. Also, Rex shows the worst results for LibreOffice, probably due to incomplete data provided by previous work. In general, our system demonstrates stable results and exceeds the number for the largest Qt project. To answer the second question and check if Rex is able to expand the set of actual reviewers, we track contributors who over time from plain developers become reviewers. Our goal is to estimate how many of them appear in the recommendations for the first review. So in total, over 9 selected projects, Rex finds 466 contributors and correctly recommends them for the first review. To sum up, in our work, we present a novel recommender-based approach that, compared to existing state-of-the-art, can recommend regular reviewers, and at the same time to expand their actual number by recommending appropriate developers. We also provide a rich collection of reviewing and development data used to build Rex and to conduct an exploratory study as well. The source code of the system and data are available on GitHub. So thank you for the opportunity to present our work. If you have any questions or interesting ideas, please contact us at any of the provided emails.